name is Lee, and
Ricardo.
I'm an associate professor in the department.
Uh-huh.
There you go. So I look forward to your talk.
Okay, thank you.
We'll get started.
Yeah.
All right, so let me kick things off. I know it's spring break, so we don't have as many people here. But we're delighted to have Professor Ricardo Daziano here today to talk about his research on VR and transportation systems environments. He'll elaborate more on it. So Professor Daziano is an associate professor at Cornell University. And he's done a lot of work in behavioral economics, looking at sustainability, energy use, and the nexus with transportation. He came here 2 years back and gave a talk on public transit route choices and how crowdedness impacts those choices. So it's interesting this time around. He's taken those images that he showed us last time and put them in a more immersive environment using VR. So I'm very interested to see what he has in store for us. And this work is actually funded from the CTEC, Sister University Transportation Center up in Cornell. So let's see what that's all about. All right, let's join me in welcoming him.
Well, thank you, and thank you for coming over spring break. When we planned this, we kind of didn't realize that it was spring break. So yeah, I'll be talking about this exploration of the use of immersive environments in transportation behavior analysis. So the things that you'll be seeing, they are at a very early stage. We have the technology, and then we want to understand how this technology can be used for helping us to understand better how people behave. So the context is experiments in travel behavior research. They're obviously not new. There is a very long tradition of doing experiments. But traditionally, when we think of an experiment for travel behavior research, we think of stated preference surveys. So basically, you ask the individual to elicit preferences, and the main concept there is that you are controlling the conditions. That's why it is an experiment, right? So then you want to identify the causal relationships between the things that you are changing in that control environment and how the individuals react as the response to that and that stimulus. So it's hypothetical situations, and all that leads to the main context of discrete choice experiments. I'm a choice modeler, so the main kind of modeling tool that is underlying here will be choice models. So traditionally, discrete choice experiments, they use very highly stylized scenarios. So you think a very traditional choice experiment you'll be looking at, and we'll see some examples in a couple of slides, just text describing two or more alternatives, right? And then you have to decide which one you prefer, and that's usually in the context of a survey. So there has been some evolution in that. 10 years ago, all surveys were just on paper. Then 5 years ago, they were online, and that was kind of the new thing. Now, even that is becoming kind of old school because of the emergence of the things like VR that I'll be talking about today. So there's a lot of work on choice modeling about attribute non-attendance. So that's when you have an attribute in the experiment, and then you notice that people are not paying attention to that particular attribute. So then there are kind of two explanations that are behind that fact. One is that maybe people don't care about that attribute, Or maybe it's your experiment, the problem, and not really the context, the choice context. So maybe, it's an attribute that presented as text. If you're using a very traditional discrete choice experiment, maybe that's the reason behind people being inattentive to that attribute. And then as additional motivation, we now have sensors everywhere, and then that's changing completely the transportation ecosystem, as you're very well aware of. So we're moving to our new modalities. We have new technology in transportation, but that's not only on the supply and demand side, also for data collection, right? So we have new tools, we have new technology, and that is as a subject of study. So new modalities, microtransit, TNCs, autonomous vehicles, electrification of transportation. But at the same time, as I just said, also in the design and data collection dimension of transportation, we can use this new technology. And one of them is simulators and the use of VR. So the thing about VR is that it offers a highly realistic immersive simulation of a condition. So near real 3D experience, right, of unfamiliar conditions. You can use it to test products and services. You don't need to invest in the actual product or service, and then you can test how people react to that. So the technology has been evolving quite quickly as well, and then with your phone and some devices, you can very cheaply have VR type of interaction with a respondent. And all that is kind of coming in parallel from gaming environments. So it's there where the technology is kind of evolving very, very quickly. And then for us as transportation researchers, we are using these new tools to capture behavior. In the context of the models, as I announced, I'm a choice modeler, so I'll be talking about how we can use this VR technology to model behavior using econometrics. So I'm sure you're familiar with this, but in econometrics of travel behavior, we're usually interested in compensatory type of behavior. So we're analyzing trade-off between, for example, what is the willingness to pay for some service, what's the actual price, and then from there we basically can predict behavior. So in that context, then, kind of a main question that we could ask ourselves is how to exploit this VR technology in the context of choice experiments. And then how we use that data that we'll be collecting, choice data, using this technology to enhance the behavioral models that we currently have. So I'm not the first one doing this type of research. So first I'll be going over some examples of existing research, and then I'll be talking about what I am doing. So this is not the first study, but if you look at the literature now, it's one of the first recent studies that used in the context of transportation, even though it's neighborhoods, and so it's really kind of urban planning type of example. So here they compare text only and virtual reality for a discrete choice experiment of neighborhood choice. So they carried out first just a very traditional discrete choice experiment, right? Pretty boring. Everything's just text, but this is how everything was done, before. So there you have the attributes, two choices, and then people had to choose between two neighborhoods. And then using a multimedia version of the survey, which basically exploited a gaming platform, people could pan over two neighborhoods, and then while they were panning through them and then doing kind of a walkthrough, but this was with a screen. Then some information about the neighborhood appear on the screen. and then you were asked to choose which one of the two you would prefer. So as I said, they were not the first. In architecture and urban planning, there's a longer history of doing this type of simulations for their own research. But one thing that is very interesting in this particular study is that they didn't find a whole lot of differences between the estimates between the text-only version and the virtual reality environment. The only difference was that in text, people were kind of more disliking this type of neighborhood when it was described as kind of townhouses in text, but once they experienced it in the walkthrough, they actually didn't were as negative as in, but it was a very marginal difference between the two contexts. But one difference that was very, very interesting was that even though for the preference parameters, there was not a lot of difference, the sample size was basically the same, but using the sample for those who saw just the text only version of the experiment, they couldn't add a whole lot of sociodemographics to basically create segments in how people varied in the preferences. When they used the simulator, they were able to capture this heterogeneity in preferences. This is another example. So this is impact of smartphone distraction on pedestrians' crossing behavior. This is from Bilal Farouk in Canada, and we'll see later another work of him, and that is using VR as well. So in this case, basically they had 3 conditions. So you were at an intersection and you were asked to cross multiple times a street. And then in one situation, you were asked to just do it taking care of the environment and not being distracted. In another one, they said, okay, just check your email while you are being asked to cross. And then the third condition was the same. You're looking at your phone, but this was using a headset. They added some LED lighting on the floor. So while you're looking at your phone, you could see if for example, the traffic light is turning green so that then you can cross. And then they look at how people were reacting. And this another very interesting work from Bilal's research group. In this case, what they were doing is analyze an intersection where there is autonomous vehicles. So the thing is that for the current scenario, there is a signalized intersection. So you have traditional cars with drivers, you have the intersection, and then you're asked to cross that signalized intersection. Then they had autonomous vehicles, just autonomous vehicles, so it was an unsignalized intersection. So there's no signal for you to cross. You would cross, you had priority in that crossing intersection, and then the cars just stopped for you. So the thing that was very, very interesting is that they did basically 3 treatments. So they explained these 2 scenarios of the intersection just with text. Then they explained it to another group of participants with a video showing the signalized traditional scenario and then the autonomous vehicle scenario, just with video, and then people experiencing it with the headset. And then the choice context of this was pretty simple. After experiencing or after reading the description of the 2 scenarios, they were asked which intersection they would prefer. So it's not really a choice experiment. There's no variation of attributes here. It's just you're given 2 alternatives and you're being asked what of these 2 worlds you prefer. So when they had the text-only description, 50% were people who were basically indifferent. 50% chose the autonomous world. Then when they had the video, just 40% of the respondents preferred the autonomous world scenario. And when people experienced it with the headset, then 70% of the respondents preferred the autonomous scenario. So what happened there is that you probably have seen simulations of intersections with just autonomous vehicles, and you see, everyone is just going. So if you look at that kind of video, even though you see that the cars do stop for a pedestrian that is not you, right? It seems like a very risky kind of situation. That's why people were kind of afraid, and just 40% preferred that. But once you experience it yourself and you're trying to cross and you see that cars are actually stopping, then that explains the observation that they were having. This is very interesting work because it's something that kind of you read this and you say, oh, there's people working on this and it's pretty neat. So this is using virtual reality to assess the street crossing behavior of pedestrians with simulated macular degeneration at the traffic circle. So they were analyzing, and this was funded by some health type of agency. So there is some kind of macular degeneration problem that people have like a problem in their retina, and then they see basically, as you're seeing here, a black spot, so you don't have full vision. And the thing that they wanted to know is basically controlling for the size of that black spot in the retina. How would that change affect your behavior of crossing the street? So they controlled that with people who had perfect vision, but you're using this VR headset, and then they could control that, and then you had this poor vision problem. And then basically they were able to measure how the size of that macular degeneration increased the safety gap that you would wait for the separation between cars so that you would basically cross the street. Finally, another example of existing work. There's a lot of, and they have a lot of very cool technology to do this. This is the ETH group in Singapore. So these are some of the people working on this, and there's a lot of people, and you probably are aware Kai Axhausen, he's in Zurich. He kind of oversees what is going on in Singapore, and they're doing this kind of experiments. And you'll see that one of the experiments I'm currently doing is similar to what they are doing. So the thing is, you would like to know how people react to cycling infrastructure. So for example, if you had to cycle on the sidewalk, or a painted cycle lane, or a painted one but on the street, or a segregated one. So you would like to know which has more effect on increasing the probability of someone choosing to bike, right? And then we can do it with these simulations, and you don't have to invest in the actual infrastructure. So that's the good thing about this type of environment. So when you look at the existing research and what do they say about what are the benefits and what's the value of these immersive scenarios. So one is that it is highly realistic, it is immersive, and also it can be interactive. So for example, in the case of the cycling behavior, you can make pedestrians react to your own choices. So it is interactive in that way. So a problem that we have with traditional choice experiments is the question of engagement with the experiment. And because this is so realistic and so interactive and so immersive, then people are actually engaged in your experiment. So they should be reacting better. And that will lead to better identification of the effects once you want to estimate a model and the parameters of your model. Also, we could expect a minimization of hypothetical bias. So again, right, if you're describing something just with text, it's not that near to the actual environment, but this is much more realistic. However, one thing that it's interesting when you look at the conclusions that people have, nothing is kind of expressed as a fact. It's kind of, these are the potential benefits of the technology because it's something that is being just explored. Even what I'm doing is at a very early stage. So we're exploring, and these are potential benefits, but we're uncertain up to what degree we actually will achieve this kind of benefit from using these environments. And then you could ask yourself, okay, some of the things, right, they could be solved using reality instead of just a virtual reality. So kind of a main question here is why an immersive environment and not reality, right? So ease of collection of additional information, and we'll see some examples of that later on. But the main thing is actually control. So again, it's the idea of doing an experiment where I can control, for example, how exactly looks the infrastructure. I could control the colors. So it's much more flexible, and then you can design an experiment. Unlike reality, which is not an experiment where you have confounding effects, and you cannot estimate your parameters in isolation of those confounding effects. So now let's move on to some of my ongoing research. So the first one, as Joe was mentioning, is related to the high density of passengers in transit. So the motivation for using VR, so if some of you were here 2 years ago when I presented my crowding research, once I was just browsing over pages at Cornell, and then I realized that there was this professor, So-Yeon Yoon, at the College of Human Ecology at Cornell, and she's doing research on crowding using VR, but in a completely different context. She's using it for retail environments. So she's looking at the things like, for example, store layout, and she makes people walk around this virtual store. And then in this case, is one of her papers. They had basically 4 conditions, right? Grid-based layout or a free-form layout, and then low density of clients and high density. And then people walk through these 4 conditions, and then they answer some kind of survey of user experience. What do they like? In which store they would be spending more money? That kind of type of question. So it's not a choice experiment. Very reduced in terms of the number of conditions that they have, but pretty cool idea. So then I talked to her, right? She was doing research on crowding, and then we started collaborating a couple of months ago. And she's helping me with the designs that you'll see of the VR conditions because I have no idea how to do that. So one thing that we are doing is walking through crowded terminals, and in particular airports. So what we want to do here is kind of connected to the type of work she does in retail environments. So we're interested in perception of quality of service at the airport, so user experience, waiting time perceptions, see if it's more crowded, do people feel like they're waiting longer, walking through terminals, intentions to shop and dine at the airport, and see how that is affected by the crowding levels. And also interventions, and by that I mean the following. So in this case, what we're doing is, this is in the subway here in New York City. It's a virtual thing, but inspired by some things that happens at airports. So this is the O'Hare in Chicago. This is the Detroit Metropolitan Airport, and probably some of you have experienced this, that you move through terminals, and then this is like these art installations. And in addition to being nice and interesting from the art perspective, Actually, people feel like the walking time is shorter. So then the user experience is better for them. So then we were doing something similar in the context of the subway here in New York, where sometimes you have to walk a whole lot to another line. And then what happens if there's some kind of art installation and how that affects your perception of time. So talking about time perceptions, in psychology, they distinguish that subjective time is not the same as objective time. And then there's empirical evidence that negative emotional arousal increases estimates of subjective time. So for example, and then it's kind of funny, the experiments that psychologists do. So for example, sometimes it's kind of strange. They ask you to kind of look at a blank screen or to look at a screen with spiders on them. And then they ask you, okay, how long were you looking at this image? And then they have realized that, if you're looking at spiders, that time seems longer. Then other things, like approaching a stairwell versus getting away from it, the time perception is different. Free fall, if you look at someone jumping on a bungee, it's not the same time perception as yourself doing it. It feels much, much longer when you are doing it. And crowding is a negative experience, so that should create arousal, stress to the individual, and that should increase the perception of duration as well. But this, even though there are elements here that sound different than what we do, there's some elements that are very familiar to this notion of that there's subjective time, right? So then, hypothesis that could elaborate here, high density of individuals, it induces an unpleasant feeling, then it will increase physiological stress and arousal. This will become very relevant in a couple of slides, and that's why I'm talking about this now. And that will ultimately increase subjective perception of the duration. So then the connection of this kind of more psychological side of time perception to what we do is the following, right? There's then a relationship between this psychological distortion of time and what we call in econometrics the marginal disutility of time. So time perceptions in transportation economics, right? We measure that with that marginal disutility. So we have that utility, we have a beta time, right? And that beta time represents how individuals perceive time. So then we are very accustomed in transportation to work with things like, okay, we know that the value of time for travel time is less than the value of time for walking or the value of time for waiting, right? Usually waiting time, you say, is valued twice as high as in-vehicle time. So that is related to the notion of it's a distortion in the perception of time. So then all these related to crowded subway systems and how we could measure those time distortions and how do affect and the decisions made by travelers. So subway crowding is a problem. It's a very bad problem. This is for New York City. You can see what is causing subway delays, the number of incidents per year. And then there are a lot of potential causes for the delays. But most of them, except overcrowding, they have been kind of stable over time. Overcrowding is getting worse and worse, and you live here in the city, I don't, so you probably have noticed this much more than I do. And that's creating a whole lot of delays on subway. So from an econometric perspective, we can think of marginal rates of substitution in this particular case between traveling under uncrowded conditions and traveling under crowded conditions. And for that, we can define what is called in the literature a crowding multiplier. So a crowding multiplier really is, this is in terms of the actual utility functions, but basically is the same notion that they have in psychology of the time perception, but tied to the concept of what is creating the negative feeling that makes you think that the time is longer. So when you're walking, it's more tiring. That creates the longer perception. In the case of crowding, the high density of passengers is not a pleasant feeling, and then you feel like time is longer. And then the crowding multiplier basically is how much longer you think the travel time is as a function of the density of passengers. So basically what I presented 2 years ago that's published now, that's a context for a study we did in Santiago in Chile, in the metro system there. And we estimated these crowding multipliers by using traditional discrete choice experiments. Not full traditional because we showed pictures of crowded subway cars, but it wasn't immersive. So how crowding can impact travel decisions? Well, for example, if it's within the same route, especially here in New York, you could take decisions, for example, okay, I say that the express subway is coming, it's really overcrowded. Obviously, it's faster, but maybe you could take the local, which will be longer in time, but maybe it's not crowded. So if you knew that it's not crowded, then you would have this trade-off, okay, should I take the crowded one but faster or the local one? Maybe it's so crowded that you will think of switching route, but stay on the subway. So take another line. Or maybe it's so bad that you would switch to another mode. And this was what I used for motivation 2 years ago, which is still true every time I go to Santiago. So that's the now it's actually bigger, the system, they have more lines, but still pretty bad, and you have to do the same thing. So I was staying in this section of Santiago, and I was visiting the Catholic University, which is over here. And then to go back in the afternoon, the obvious route was to take this line and then that line there, and I would be arriving. But I didn't do that. I went in the opposite direction, so going away from my destination. Then I took this line, so I added one more transfer and another transfer, and then I arrived. And doing that, actually, it added 30 minutes to my trip. But if I did the shorter in time choice, I would be facing these conditions, and I traveled like this, longer, but I traveled like this. So I did, yes.
How much was the base time?
It was 45 minutes on the shortest, yes.
Did you do this experiment, like, did people have the two choices between the comfortable longer one and the uncomfortable?
So what you do, basically, when you do a choice experiment, you could present, suppose that you have kind of full information, and then you would have these two, so that's why it's hypothetical in that case. Suppose that you have an uncrowded, and you could actually have a specific density of passengers. So let's say 5 passengers per square meter, and this travel time, and 4 passengers per square meter, and this travel time. Which one of the two you would prefer to take? So in the case of Santiago, we did it with pictures. And now that I discovered this person at Cornell, we're exploring the use of VR. So we have been running some very preliminary experiments to then later, hopefully if I get some funding for this, to do a larger experiment. So we're working with 5 virtual reality conditions based on the density of passengers. So it's a VR recreation of the subway here in New York. And while people experience this, we're also measuring their physiological measures. So to have metrics that we can use, for example, to get a notion of how much arousal, how much stress the higher density of passenger is creating in the respondent. And for that, we are using a wristband that can basically measure heart rate, skin conductance, and body temperature that in psychology they actually use as proxies for stress and arousal that would explain negative feelings.
Ricardo,
Oh.
just after seeing that last picture you showed, it made me think about if viewpoint height has an effect on the negative emotional arousal. Like imagine if someone's shorter in stature, they like you experience more congestion, whereas that viewpoint was sort of above the crowd. Is that has that variable showed up in research?
Yeah, so we are asking, so you adjust. So the two dimensions in your question. One is your actual question, and the other one you mentioned, but it's relevant too, which is we need to calibrate the height of the person, because first we weren't doing that, and then people say you felt like a giant because it was like above. So that had the positive thing that it was better, because then you could see kind of better what was the crowding level. But then you felt like powerful because everybody was small. But yeah, so we're asking, so now we are adjusting it to the height of the person so that we would see what they actually would see according to their height. And we're recording the height of the person so that later maybe we could be exploring the connection between height, for example, and the negative feelings of the crowding level. So it's a very good point. Okay. So this is kind of what people are experiencing in this, but wearing the headset, right? So just a subway, but with kind of fake-looking people. And that's one of the challenges I'll be mentioning later is still it kind of feels like a game, right? So yes, it is immersive, and it's better than just looking at a picture on a screen, but still it's not reality. But it's getting better. The other weird thing, I don't have it here, but so for example, when you have very high crowding, then it's like this guy and that girl, they appear several times in the same, so then we had to change that. Oops, okay. And much less cool than that video is, this is someone actually participating, and so just right, standing on a lab. It's not very, and that's another thing that we had to modify. Now it's better, but at the very beginning, we had to have someone like that for the wristband because it was just collecting too much noise if it wasn't stable. But now we had calibrated it. So we have been doing the following experiment. So first we have a task where the respondent is experiencing 2 crowding levels, randomized from the density of passengers from 1 to 5 per square meter. Then there is like a dark scene between the 2 conditions. Both conditions last the same, but we don't tell people what the duration is. We don't tell that they'll be asked about what the duration of the trip is. And that makes the distinction, which comes from psychology actually, retrospective versus prospective time perception. So the first one is that you make someone experience something, and after that, without telling them that you will be asking them about their time perception, then you asked the question. So then it's recalling the time. But once you do that, if you have more conditions, then people now know that they'll be asked about the time perception. So that's what is called the prospective time perception, because in that case, they know they'll be asked. So they didn't know in this first task, and just two conditions, so that, because if we had too many, we couldn't say, okay, how long was the third one, how long was the fifth one, right? It's just too many, so just two. Same duration. And then the question was, which interval was longer? And how long were actually the order is different, because we didn't want to have that one first, because if you say that one first, then they may think that one actually is longer, and they weren't. And after that, we had a second task, which was prospective time. So in this case, they are experiencing all the 5 levels of crowding. So they're randomized, but suppose for someone, they'll see 1 passenger per square meter, again, randomized by saying 2 passengers, 3, 4 passengers, and 5 passengers per square meter. But also we were randomizing, in this case, the duration. So some of the simulated trips were 60 seconds, some were 70, and some were 80. But now people knew that they were going to be asked about the duration of each of these trips. And then, because there are too many conditions, we have questions right after each of the levels they are experiencing. So actually running these experiments, it's pretty time intensive. It takes per participant 45 minutes. So you have to make them fill a consent form, right? We needed IRB approval and everything. Then they have to have a demo trip, so that, because the first one, they're really excited about the technology. They're not paying attention to anything else. And also they get arousal that you would be measuring, not because of the crowding, but because of they are excited about experiencing this. Then personal information question, then adjusting and calibrating the wristband. Then task 1, just the 2 conditions. Then we recorded again the physiological measures. And then task 2, and then a final survey. So pretty long. So very, very preliminary results, and this is just with 14 people that have participated so far. So this, again, is for task 1, where the durations were exactly the same. But to the question which trip was longer, people identified the one that was more crowded between the 2 that they experienced as being the longer one. There's a lot of variation.
Did you also allow them to say that they're the same?
Yes, they could say that it was the same, yeah. It was a ruler, yeah. So it was like the first one or the second one, and then in the middle was like they were the same duration. So there is a lot of overlap in the confidence intervals of the time perception difference. But in terms of the means, it's significant even with these 14 participants, but we're recruiting more, and we will try to see what happens later with more participants. So from task 2, and again, this is just with 14 participants. Here what we did was, okay, we were asking them to estimate how long the duration was. And we know, obviously, what's the actual time of each of the conditions. So we took the difference, and then we took an explanatory variable for that difference, the crowding level. And this estimate that we got for that crowding level to explain the difference between estimated time and actual time was significant. And then we did it with same estimated time minus actual time, but instead of using the true density that was in the condition, we also in the survey asked them to state what they perceive as being the density. And when we used the perceived density, the effect actually was larger in that, explaining the difference.
Just a quick question.
Mhm.
Do you have a quantification for the crowding level? Is it density or?
We're using density, yes.
Okay, so what's the threshold for what you mean by crowded? Like, is it 5 people or 10 people?
So we're using, for the analysis, we're just using as a function of the density without having an actual threshold for the analysis, so, right? But 6 passengers per square meter is considered technical capacity. So the cars are designed for having 6 people in a square meter. We use 5 because having 6, and that it's another problem with VR. 6 is really, really tight, right? You'll be touching everybody with 6 people per square meter. And we cannot recreate that condition in VR. Because you'll be observing people like this, but you're not, yeah. So another thing that we're doing, this is kind of open the door, and then we're doing a lot of things. I'm helping So-Yeon to do choice modeling in her research in retail environments, in this case a restaurant. And we want to see, for example, how noise and the crowding level affects, for example, we need to wait for a table at the restaurant. So we will be conducting an actual choice experiment, and so we're just designing that work now. The other project that I'm doing, and this is the one that is funded by CTEC, so this kind of sister center that we have at Cornell, is for cycling demand. So similar to the work that they are doing at ETH in Singapore. So active travel demand, we have a lot of problems to understand it and how to predict it, because the usual trade-off that we use to model travel demand, right, is travel time and monetary cost. Walking is free. It takes usually longer, so that trade-off doesn't work anymore. Cycling, the operating cost of cycling, unless you're renting a bike, it's free too if you own the bike. It takes long time and it requires physical effort. So again, the trade-off between time and cost doesn't apply here. So there has been a lot of work that has identified that active travel demand is affected by subjective attributes. So attitudes, for example, you want to be healthy, and then you decide to use an active transportation mode. But how do we measure that with an actual attribute for the choice model? So one way of doing that is using the integrated choice and latent variable model, hybrid choice models, where basically you would use latent variables as explanatory variables in your utility function. Oops. And there is, for example, this is a review paper where we discuss a lot of papers that have been looking at the use of latent variables in explaining choice for bicycling. So this is kind of my usual type of talk looks like, with lots of equations. But I'll explain it fairly easily, I hope. So first we have the utility function. So your utility function that will explain in how people make choices. But in that utility function, and that utility function is measured by what people actually choose, right, based on maximizing the utility. So just the traditional choice model in that case. But in this utility function, you have standard attributes, let's say cost and time in X, but then you'll have latent variables, for example, being healthy, let's say, measured by that Z star variable. So it's a latent variable. So then you need an equation to explain that latent variable. So that becomes, right, the variable that you want to explain. But you don't have an observation for Z star because it's latent. So then you need to measure it somehow. So suppose that you have a study for cycling demand, and then let's say you have the health concerns as a latent variable. Then you would ask people to kind of state how they self-report their health level, how they self-report their interest in being healthy. So a lot of these hybrid choice models, they're based on self-reports of indicators for the underlying latent variable. And then I won't spend time on how you estimate these models. But that's what I do. I work on how to estimate these type of models. So there is a lot of work on this, but at the same time, this work has been showing that these self-reports for the indicators of the latent variables, they lead to pretty weak structural relationships. So it's very hard to forecast with these hybrid choice models, for example. So then there's consensus that we need more reliable indicators for the measurement of the latent variables. And that's one thing that we're trying to do with these VR conditions, where we're also measuring the physiological metrics, because we want to use those metrics as an objective measurement of emotions, right? And then we have, for example, stress, and then how that stress affects your decision, measured not just by a self-report, but by an actual measurement. So that's what we are trying to do in this particular project, which is starting. So I don't know if we'll have findings or not, but we're trying to do it. So in this case, what we're doing is we have an instrumented bike, and people will be looking at different cycling conditions, similar again to what I showed you for what they are doing in Singapore. So for example, you could try to see what kind of emotions and decisions you see in people who use, let's say, a segregated bike lane, so safer. In this case, okay, it is safer. It is bi-directional, for example. So then how you react when you have another biker coming in the opposite direction as you, and then we will compare with another condition where it's just a unidirectional segregated one, or what if you're just riding your bike on the street, and then we can control the cars, and then we will be measuring the physiological measures. So then we'll see, for example, if the car is too close to you, how stress is being affected. Yes.
The car still can't come to the bike lane. I mean, in New York, it's still offloading, onloading. The bike lanes are not really bike lanes.
So
We have to.
what we are modeling now is pretty polite and respectful drivers, but yes, we can do that too, and that's kind of the beauties of the virtual reality environment, is that if you would like to do this with a real environment, you wouldn't do that, because then you're, posing a risk to your participant. But in this case, you could do that because then you won't harm the participant. So again, this is kind of how the conditions are looking like in terms of, and then we'll be doing things like kind of evaluating the risk of being doored when you have the parking on your right, and measuring that kind of effect.
So in these experiments, are there sound effects too?
Yes, yes. Mm-hmm. So a lot of things going on in my own research, a lot of things going on in terms of the technology, but it's an open research question. There's a lot of people trying to understand how this can help it's very promising, but we don't know yet if it actually will help or not, or if we'll need to make modifications to the technology so that it actually help us to answer some of the questions that we have. So we do have some benefits that we have been identifying, basically how realistic they are, right? Then we can detect, for example, how the built environment influences perceptions without incurring the cost of actually modifying the built environment. So, for example, from what I understand in the case of Singapore is that they currently don't have good cycling infrastructure. So they cannot evaluate in reality what would be the effect, for example, of a cycling lane versus a segregated one because they just have nothing. Then the potential, at least in theory, of people being more engaged in your experiment, and then you'll be more confident that the parameters that you'll be estimating, they are reflecting better the actual perception that you would have in a real environment. So that creates enhanced validity of the responses. Again, think of that scenario where it was text describing two neighborhoods, kind of very, very abstract, versus actually browsing them. So we also have been talking about managing risk without really exposing the participants, but at the same time, right, the participant knows that he won't be killed by that car. So maybe people would be more risk-taking. In the case of a VR environment, still feels like a game too. And in a game situation, you're risk-takers usually. So we need to kind of also take control of that and see how we could maybe calibrate if we're measuring risk behavior that maybe kind of depart from actual risk aversion they would have in a real situation. There are lots of challenges as well. So visualization of the experiment conditions is one. So we want to make things realistic. And at the same time, maybe if we do things too realistic, we are creating confounding effects. And then ultimately, if this just mimics reality, then we have the same confound effects that we would have in reality that wouldn't allow us to basically. So for example, if we add noise, then there's the question of, is the noise affecting and there's, so for example, in the retail literature, for example, things that we don't think of as engineers, the color of the restaurant influences how much you're willing to wait at the restaurant. And probably an engineer, he won't pay any attention to the color of the environment that they are designing if they are testing something. And so for example, if you're doing research about how the built environment looks like, we probably will have a certain tendency to make it very, very realistic as, for example, the cycling conditions, buildings that look like New York buildings, right? But then when you look at work that architects do, this trade-off between abstraction and realism, they go kind of the opposite direction. And then, for example, they present things like these. So sometimes, this is not exactly it, but this is a Professor Technion in Israel. I was at one of her talks at Cornell Tech, and she was doing research about willingness to pay for real estate as a function of the vision you would have from your windows. And then basically was density of buildings, the variable that she was controlling for. And she presented, it was very abstract, the density. So it wasn't like a realistic scenario, the buildings. So again, right, it's the condition of, okay, how much abstraction we present or how much realistic the situation is. And if it is very realistic, we should account for that in the model, how that could affect the decisions. Then one thing that we have been getting feedback from in the case of the subway, they say, this would be very different. It was the summer Yes, right. Yes, in these conditions, it's very crowded, but it's clean in that respect, and it's not, you're not being touched, you don't have any bad smell, and it's not hot or anything. So, in that respect, and we don't have that realistic conditions.
How do you create smell?
Well, I don't know. Yeah, just kind of an open question, right? You, hmm? Oh yes. Well, this is uh, completely unrelated, but it just made me think of kind of an ooh moment. I was in New York, in the UK, and there's the Viking Museum, and it's like a very small ride that you go in. This like a Viking town, and there's one Viking like going to the bathroom, and you can smell the it's very disgusting. But you could do something like that. Then, right, again from gaming, right, the people that we currently have in the subway, they look very fake. But when you look at, for example, soccer games, they have been going from this or even worse than this to people in the game that look like the actual players. So we could have, it would be more expensive, but we could have very, very realistic people. But then again, it's the question of confounding. And so, for example, and sometimes it's kind of surprising that with the existing platforms, sometimes you don't have full control of some things. So, for example, Soyeon, she was in Korea, and she was trying to do some of the work that she does with restaurants, and then she presented the conditions, and then she got the feedback that everyone is white in your environment, and she couldn't add Asian people to the environment. So
Because they don't have the model for Asian people.
not in the platform that I don't know if it was like an additional thing that she had to buy or yeah.
So which colors are better to wait for restaurant?
Um, so usually pastel colors. If it's
What's pastel?
well, it's like
What is pastel?
yeah, it's like light blue or pink or yeah. Yeah, calming colors. Yes, if it's red, then you tend to go away. Yeah. So another case of too much information coming from the VR and also matched with measuring, for example, physiological measures, is that maybe we will have like just too much information, too much noise. So that's one thing that we need to discover, right? So because we could look at face reactions while we're doing these verbal reactions, brain activity, measuring stress, arousal, etc. And then what do we do with all this data? Is it helpful or is it not helpful? Do you have a question?
Oh, I was just wondering whether you use the motion capture to detect the body language of the person and then infer what kind of feelings.
So people in psychology, they are doing that kind of thing, but then, so they're collecting a lot of data, but then their experiments are super, super simple compared to what we do. So again, it's kind of a blank screen versus a screen with one spider. And then they measure a lot of things, but the actual stimulus is fairly simple. And then if we want to do this for a natural choice experiment, how do we elicit the choices, right? Because, for example, if you want to make them choose between this neighborhood or this neighborhood, then it's a question they experience first one of the neighborhoods and then the other neighborhood, and then you need to ask which one of the two you prefer. And then maybe we could be asking for pairwise comparisons, but then if we want to add another type of neighborhood, do we do it by pairs? Do we make them experience all three? Do we make them make choices along the experience? If we do that, we don't have currently a lot of tools to do that. So again, a lot of open questions. And then one key thing, I'm come from economics. So in my head, the main attribute of a choice experiment is the price attribute. but the price attribute, you're not seeing it in these VR conditions, right? So then there's some evidence that when you're using these immersive environments, and then you could say, okay, now that you experience, let's say, these 2 hotel rooms, how much you would be paying for these. And then people pay less attention to the attribute because it's less immersive. It's not, you're not actually paying. Maybe you should give the credit card to some fake cashier or something, but it's unclear if people would be giving that much importance to this price attribute compared to the immersive attributes. And then we have the question about how we elicit the choices. So it could be passive. So for example, if we are measuring trajectories, following trajectories that people are, how they browse the environment and kind of route choices, then we could do that passively, right? Or could be active conditions of choices, and maybe we could do that with a joystick, or choice from a menu that sometimes it appears on the screen and they make a choice, like a game kind of thing. But it's unclear. And then the other thing is that, okay, this is pretty cool, but then it takes a long time per participant. So for example, when you look at the published research and the few that there are, they all seem to converge to they have used around 40 participants, which is not a whole lot to, for example, estimate a choice model. You could still do it, but it's not a super large sample. And then if you want to record trajectories, for example, usually if you have a lab now, you can do so typically in a very limited area. So you can like walk around a little bit and then it stops. But now you could have something like this. So it's kind of like a treadmill, but you can walk on any direction and then you just keep walking, and then you could walk for forever and then kind of trace the trajectory of a pedestrian, for example. And there are instrumented bikes. Usually what they can measure is acceleration and braking, and then the VR adjusts to that. Steering is more complicated now. It's not resolved. So if you want like to measure, okay, people want to go straight or change to a different street, that's hard to do now with the technology. Motion sickness is another problem. So people do this and then they feel very sick. So then we do have a cost and time trade-off for the experiment, right? It's longer, takes much longer than the traditional. An online survey with the choice experiment can take 5 minutes, right? And then in a question of an hour, if you have an online panel, convenience panel, you could have 500 responses, right? And in this case, you could be months, and then you have just 40 participants. And then, there is technology, for example, to allow you to track trajectories that are unlimited, but then you would need to buy this kind of thing, so then it's very costly in terms of a lab. So as a global summary, there's very exciting research ahead, a lot of open research questions, and we're just exploring what comes with this technology and what's the value that hopefully will bring to travel behavior research. Thank you.
Any questions?
Yeah. So for the 40 people doing the experimental in the subway car, do you have like the baseline data? Like, do you check what those guys really feel, or the time perception of the time in the real stuff, the practice?
No, we haven't done that yet, and applying for funding to do that kind of exercise here in New York. All these 14 participants are students in Ithaca.
Oh, okay.
So yeah, it's.
Yeah, but I think that is a good way to tell the abstraction versus the realism.
Yes.
So, yeah, use that data tracking between the VR and the how they feel in the real world.
Yes, in the proposal that hopefully will get funded, we are proposing to compare against that baseline. Yes.
Okay. And one more question is, if I remember correctly, before 2 years ago, you presented like different layouts in the bird view of the subway car to see the facility, the seats layouts will reflect the crowdedness of the people. So I think, do you also include that into the VR experimental? Like you use different layouts of the seats in the subway car to see how people feel different.
Yes, we are planning to do that. It's not something that we're doing now because this is kind of to get preliminary results that we could use to show the feasibility of what we are proposing. But if we get funded, yes, we'll be also changing the layout and see how that affects the perceptions. Yes.
One more question. About the structural equation modeling, have you encountered the identification issue while doing that? I mean, so do you specify a specific structure for the factor loading matrix while doing the structural equation modeling?
Yeah, but that's unrelated to this. Yes,
no,
yes. It's for the econometrics. Yeah, right. Yes. So yeah, so you do need some identification restrictions, and then.
Right. Okay.
Yeah. So you need to kind of fix the scale of the latent variables and.
Yeah. And do some modification to the loading matrix, maybe.
Yes. Yes. So it's kind of the traditional
way of doing it.
Yeah. So you basically, for example, you set to one of the lambdas of the loading factors, and that allows you to identify.
All right.
Yeah.
Thank you.
I have a paper on identification on.
Oh, really?
Yes.
Yeah, can you send it to me?
Yes.
Yeah, so I have a couple of questions. One is regarding the modeling bikes. So you said you're doing latent variables for health. What about the other factors that you mentioned, like perception or like how cool a certain mode is? Like, have you found quantitative ways to measure that?
No. Yeah, that's an open research question. How because there is a lot of different dimensions.
It's also very context specific.
Yes.
I feel, because I don't know if it's the same in Chile. Like in some countries, I think like car is an aspirational thing and it's considered a different way. Whereas in like Brooklyn now, if you own like a hipster bike, it's very cool and want to do that. But also the second question, you mentioned something about interventions. Have you done any VR-based work where intervention is involved in like before after behavior?
I haven't, and I'm not aware of any study that has done it, and that would be a true test of yes.
This would be a very good use.
Yes, exactly.
There is a lot of like information-based interventions and like some visualization and stuff, but this is like actually placing someone in something and seeing if we can actually get like long-term effects rather than just giving like incentives.
Yes, I agree, and that would be a fantastic thing to do. Yeah.
For those VR experiments, do you consider also trying to vary the time durations? Because it seems like the longer they stay in certain situations, it would vary in the response.
Yeah, so we're currently varying. So for the first task is the same, but for the one we're experiencing the 5 levels, we're varying. It's not the whole range of variation because we won't have a whole lot of participants, but if we have more participants, we would have longer or wider levels of variation in the duration. Yeah.
And for your research that you're starting off with the restaurants, are you guys considering nonlinear utility functions? Because I'm thinking with crowded, some people might prefer to have a certain amount of crowded restaurant.
Yeah, so yeah, we're thinking that probably the effects will be non-linear, but we haven't even started to collect the data yet. So yeah.
You have mentioned about the unattended attribute. So how do you think like VR addresses that issue? I mean, what is this unattended attribute that we're talking about? Is it an attribute that is not attended in reality, and
so kind of The practical side of attribute non-attendance is when you have an attribute in your experiment and then you notice basically that the beta is 0. So it's not significant. So that means that people were not paying attention because then it's not having an effect on the choices made by that individual, okay? And then there are models actually that they, from how people responded, they basically try to see, okay, people actually were not paying attention to this attribute. So then suppose that you have an attribute that, so suppose that you do, for example, the crowding experiment of the 2 subway routes. And then suppose that I estimate that model using text description of the crowding levels. And then I estimate my model, which will be a function of travel time, travel cost, and crowding. And let's say that the beta crowding is not significant. So my conclusion would be that people were not attendant to crowding. So they didn't care about crowding. And then suppose that I have another sample with the immersive scenario. Same conditions, but now in the data, when I estimate the model, the beta crowding appears to be significant. So then I have now evidence that maybe people were more engaged, and because now they actually felt like what it is to be with 6 people in a square meter, then they were responsive to the attribute. So in that respect, it helps you to kind of clarify that it's not that people in reality are not attendant to or non-attendant to the attribute, but it was just maybe how you were presenting the experiment. Mm. So it's a question of how engaged the respondents are. Mm-hmm. Anything else?
So let's thanks.
Thank you.
And you'll be around in a little bit, so you'll
Thank you.